Do we have notes on the probability already? Daily, do we have notes on the probability? We have not done probability, it must have been all the other classes. Okay. Probability, if you're defining it, is basically the likeliness something is going to happen. And generally, we state probability in the form of a fraction. And it kind of looks a little like this. Here's our probability line. Okay. If something is not going to happen, or if something is impossible, if something is certain not to happen, or impossible, it has a probability of 0. Okay, if it has a probability, if it's absolutely positively going to happen, or if it's certain, it has a probability of 1. For example, the probability that today is Thursday is a 1. The probability that today is Wednesday is a 0. Now, in between that, if it has a probability of 1/2, okay, it is as likely as not. As likely as not. And things that would fall into that category would be if you flip a coin, they're supposed to be fair. You know, the probability of flipping a head would be 1/2 because it's as likely as not. Okay. Now anything that's smaller than 1/2 is called unlikely. Anything that's bigger than 1/2 we say is likely. But again, remembering it's probability. You know, just because something has, you know, a 7/8 probability of happening, is it going to happen? No, not for absolutely positively sure, but it has a high chance of happening. Now, what we have to look at here, there's a couple definitions here. Draw this little spinning wheel here for you. Let's do it like this. A, B, and C. A, B, and C. Spinner. The book will ask you sometimes to give the sample space. If they ever tell you to give the sample space, they are just asking you to give, list all the outcomes. In other words, if you're talking about this spinner, the sample space would equal, you know, what are the different things that could happen when you spin that thing? You could either get an A, you could get a B, or you could get a C. That's your sample space. Now, that would change if I asked you this question. What's the sample space if you spun twice? Well, in that case, you'd have to list all of these things. What would they be? You could get A and an A if you spun it twice, an A the first time and an A the second time. You get an A and a B. You could get A, and a C. Then you could get all the ones that have, you could get a B and a C. We already had the B and the A over here. What else could we get? We could get a B and a B. What else are we missing? A C and a C. So in that sample space, you'd get 1, 2, 3, 4, 5, 6 different combinations. I'm not sure why I put a comma there. Okay. Now, here is something else you must think about. If I asked you to give the probability of spinning an A here, and by the way, you'll like this here. the probability of spinning an A. In math, when you see the capital letter P with the parenthesis there, that means they're asking you the probability. Inside the parenthesis is what the probability they're asking you to find. This is read as what's the probability of spinning an A. Okay. You would tell me, okay, how many A's, or how many total spaces there are, and on top is how many there are of the ones you want. Now in the case that I just drew up there, and I don't know why the book uses this as its number one example, you would look at this and you might say that the probability of spinning an A is 1 out of 3. To which I would say, unfortunately that's not right. Can anybody tell me why the probability of spinning an A would not just be 1 out of 3? There's one important thing that has to be, in order for probability to work, this bottom thing, there's one important thing that has to be true. And that, Holly, would be?
Because the A is bigger than the B.
Okay. In order for you to use the total spaces, all of the spaces have to be the same. Okay? In other words, I would have to actually do this. I'd have to fix my little thing and actually make all the pie pieces exactly the same. So I'd cut them into quarters. And then think about this as having 2 A's and 1 B and 1 C, so that they're all the same. So the probability of spinning an A, how many total spaces are there? Actually, there's actually 4. How many of those 4 are A's? 2 of them. So the probability of spinning an A should be 1/2. 1 out of 2 times you should land on the spinner part that says A. If I asked you the probability of spinning a B, Charlie, it would be 1 out of 4 times, because there's only 1 B and there's still 4 parts to the spinning thingy there. Let me see what else they ask you for. Let me open up the, hold on a second, insert file. I want to go here. I want you to see a couple things here. Where we at here? How about some math stuff? What did we do before technology? Go into that. Course 1 slides. What do we have? Is that 50 something, right?
58.
58. Give it 2 seconds. I want you to go over an example problem that they have in the book here. Example, I think it's example 3. Find it here. Ah, there it is right here. Take a look at this one right here. See if we can put this in a little bit of practice. I think it's hard, I've never seen it. The question is says, a number cubed is rolled, find the probability that the upturned number is greater than 4, the probability that the number is not greater than 4. Here is the gist with that. In order for you to be able to figure out probability, you got to have a little sense about this, and you'd have to know something about a number cubed. That's just not going to do. 1 second, let me change this. Okay. What do we know about a number cubed? We call that in our modern world here dice. What are the possibilities? If I asked you for the sample space when you roll a cube, you would tell me what can you roll? When you roll a dice, what are your choices there? Alex, Tinker?
1, 2, 3, 4, 5, 6.
Correct. 1, 2, 3, 4, 5, and 6. Those the cube has 6 sides and they're usually numbered. So the question it asks you is the probability of a number that is greater than 4. Well, a little greater than simple. Greater than 4. So you look at your sample space. How many numbers are greater than 4? That's what you want, 2. And how many total are there on the bottom? 6. So your probability is 1 out of 3 times you should get a number greater than 4. Then they asked you, what's the probability the number is not greater than 4? Probability not greater than 4. It's what you'd have to ask yourself. Is 4 not greater than 4? That's a question there. If I asked you to give me a number that's not greater than 4, could you tell me 4? Colton? I believe you could, because 4 is not greater than 4. It is equal to 4. So what is my probability of a number not greater than 4? Colton, there are,
4, 6.
which is the same as 2/3. These things, ladies and gentlemen, are called complements. You might want to jot that down because they'll ask you that at some point in time. Okay. The complement really means the opposite of. You know, if I said, you know, the probability of picking a girl in this class, the complement of that would be the probability of not picking a girl or picking a boy. And the one question they'll ask in your assignment, and I'll say, they'll ask you, what do you get when you add the probability of something and its complement together? If I said, you know, if I said, okay, what's the probability of picking somebody that's not a boy, and what's the probability of picking somebody that's not a girl, and I put those two probabilities together, you're going to get, Emma Kunacek? 1, always, yeah. A number and its complement will always give you 1 because it's like saying, give me all the people that are wearing gray shirts, and then give me all the people that are not wearing gray shirts. That would be everybody. That'd be a one whole sort of thing there. All right, we got to go for another example here. We have so much to do in so little time. Let's try this one. Why did this turn there? Come on, yellow. How about this one? It says, a bag contains 5 red marbles, 4 yellow marbles, 2 green marbles, and 1 orange marble. Without looking, Brandon draws the marble from the bag and notes its color. What's the probability of drawing red? What's the complement of this event? What's the probability of the complement? Now, what do you suppose, because I know this is the question you're asking yourself, if I run across this problem in my book, how does Mr. Hahn want me to do this? What do you think Mr. Hahn's going to say, Ava?
Add all of them up.
No. The first thing you would want to do is, although that's part of it, first thing, Kendall, is yes. In other words, Kendall said draw the picture. And it doesn't have to be very elaborate. All you need to do is this. Here's your bag. What's in your bag? 5 red marbles. How do you suppose you'd show 5 red marbles? How about we just put the letter R? There's my 5 red marbles. 4 yellow marbles. 1, 2, 3, 4, and 2 green marbles. And then I want to know the probability of a red marble. See, look how I got it all on my paper. I don't have to look back at my book anymore. Did I do something wrong?
Yeah,
There's only one. Oh, and then 1 orange marble. I can always tell by the way people look at me like, the teacher's wrong again. What do we got here? Probability of red then is, how many total marbles are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many of those are red, Taylor?
3, 4,
How many
5,
are
sorry.
red? 5. So the probability of picking a red marble is 5/12. What is the complement of that? Which means the opposite of that. The probability to complement would be the probability of Sam Puppin.
1, John, 3.
Well, let's make it an easier way.
All of the others.
Make it easier still.
Anything else?
Let's use the word not.
Not red.
There you go. Probability of a not red marble, which is all the other ones, I see where you're going with that, would be what? What is the probability of not red? Ava?
7/12.
7/12. And then the ever burning question I told you they would ask. What is the probability? Oh wait. Oh, I thought they were going to ask what is the sum of the probability and its complement, which would be 1. You don't have to ask that. I don't want to do that one. I don't want to do that. Okay, now one more blank piece of paper, unfortunately. This will be short. very short, actually. On top of this piece of paper, write the word, I'm gonna stop this and read